Okay, so this could be our notes on chemical reactions. We've been looking at, so far we've been balancing equations or reactions, and we're now going to take it a little bit further, and we're going to look at trying to make predictions about if we have reactants on one side, what are the products be on the other side, and how can we characterize the interaction that occurs. Okay, so a couple of things I'll review with you. Okay, first of all, here's a chemical reaction right here. We just need to remember that these are reactants, or reagents, whatever you want to call them, and these are products. These things are made up of elements, or these elements form compounds. Sometimes they're covalent, sometimes they're ionic. And when we're talking about a reaction, it's a process where one set of compounds changes into a different set of compounds. So you have this set right here, H2CO3 bicarbonate. It changes into carbon dioxide and water. Okay, so these get rearranged and they form something new. Okay, that's where this change we see. Okay, and then how that happens though is the ions and the covalent compounds, they share differently. So you introduce some kind of energy that allows them to share those electrons differently, and they form new substances. Okay, some of these, if we took some reactants and try to make them form a product, they won't. And there's certain rules we're going to learn about that help you determine that. Okay, but so these reactions can occur, and they're just a rearrangement of matter. But the thing we have to remember always is to balance them. And then we also must remember that the reason we balance them is because of the law of conservation of matter. Because whatever we start with on this side of a certain amount of matter, we have to end up with the same amount on the other. And if we looked at this one to see if it's balanced, H2, H2, one carbon, 3 oxygen, 2, 3 oxygen. So it's balanced. We just put ones in front of everything, right? And it's done. Okay. And then with these, we just have to realize that there's different types of reactions, and we can look and see what's happening with each one of these, and then look what's happening and say that's this type of reaction. But also that helps us. So if we know what the reactants are, can we predict what the products are going to be? And we can. And we're going to learn how to do that. So if we continue on here, and there's some main types. There's synthesis, decomposition, replacement, and combustion. Okay, and we're going to add something to replacement here actually. The synthesis is where you take something simple, put it up here, take something simple, and make it more complex. It's like you're taking all these simple things, putting them together to make something more complex. Okay, an example of this, sometimes they write it in letters. A plus B gives you C. An example of this in actual equation is H2 plus O2 gives you H2O. And then again, follow the law of conservation. You have to balance them: 2 hydrogen, 2 oxygens, only 1. You need to put a 2 in front of there, so that gives us 2 times 2 is 4. Put a 2 there, and it's balanced. This becomes a 1, and we're good. Okay? But this is a synthesis. You have these two simple things, and we can even say a gas. Gas is most likely a liquid. Okay? And then we really can see what's going on in this equation. These two simple gases, these monatomic compounds made up of just one element, combine together sometimes through electricity, different conditions, and they form a more complex compound where they join together. That's synthesis. Decomposition is actually the opposite of synthesis. Or say opposite. And that is where something complex becomes something simple. Usually multiple things. So if we want to look at a different way of this, we could say if you have something complex, iron sulfide, say this is a solid, and then we do some kind of reaction to it, provide energy, whatever it may be, we turn it into iron plus sulfur. Plus solid, solid. Okay? And you can see we have this more complex compound, and then in the end we turn it into simple elements that made up that compound. That's decomposition. This can happen a lot of different ways. It could be the same as this one up here. But instead of starting off with H2 and O2, we can start off with H2O. Again, we always want to make sure that these are balanced. We have one iron, one sulfur, That's good. This one's good too, right? So we're good. So that's decomposition. This can happen a lot of different ways. The thing you want to look for is you have one thing for the most part as reactants, and then you have multiple products. Okay. So then replacement is really exchange of anions. If you remember, in a compound that's ionic, this is where they give off or take on electrons, something like this iron right here. Okay, we have the one on the left is positive ion, called a cation. Sulfur is negative, that's called an anion. And what happens is you have these reactants, and what they do is they exchange ions. Like you might have a simple element in a more complex compound, and then the simpler one takes a hold of the anion, and after the reaction, it then owns it. And I'll give you an example of that in a minute. And sometimes they just exchange both of the anions that they have. So a good example was one we looked at. Silver nitrate, so B2, and then let's say there was just copper, and this would be aqueous, probably mixed in water. Could be a solid, I guess, but we'll learn about that later. This is solid, and then we then on the other side, this copper and then takes a hold of that nitrate, and then we get Cu plus Hg. So, and then again. So we have this is a single replacement, and where this one single anion is in exchange to the other cation. Okay, and then we have to make sure they're balanced. So we have two nitrates here, we just put this two in front of there, we put the two in front of the copper, so it comes over there, and then it looks like it's balanced. You can also, though, you can have a double. And I'm going to erase this here, so make sure you have it done. You can always rewind back. Put the double up here. Okay. So the double replacement would be, I should say, instead of having just copper by itself, we have AgNO3. And so we get 2. We're going to put copper with carbonate. Carbonate is +2. We're going to say this is copper 2, so it's going to be by itself. And on the other side, they're going to exchange. So these two things are going to switch with these other elements, the cations. So on this side, they're going to have AgCO3 plus CuNO3. Okay. And this is actually going 3, 2. And then we just need to make sure it's balanced. If you remember, carbonate is -2, silver is +2, so they cancel. Then we got one silver, we have two nitrates, one copper, one carbonate, one carbonate. Perfect. Okay. So that would be our new equation, and this is called a double replacement reaction. There's actually another kind of double replacement. I'm going to put it on here. This is called an acid-base neutralization. That's spelled right. So that's where you have an acid, you mix it with the base, and you get a salt on the other side, plus H2O. Okay, so in these you're looking for the formation of salt, and you're also looking at the compounds that are reactants. Are they acids or bases? Acids are things that are formed with hydronium. Bases are things that are formed with hydroxide. So we could look at this, and these are always double replacement. And we look at silver. There's no hydrogen. There's no hydroxide, and they're going to have to work together for this to occur. So one of the compounds has to be acidic, and that will be aqueous, and then the other one has to be basic, and it would also be aqueous as well. I'm going to give you an example. So I'm going to erase this. And this looks like the following. So we would have HCl. It would have to be aqueous. As soon as we saw the aqueous, we'd know it's probably an acid. And then we would have OH. It's also aqueous. Okay. And then what's going to happen, these are going to switch. So the sodium is going to take chlorine. And then the OH is going to take the H. So it's going to be H, OH, and really that equals H2O, right? So we're going to rewrite that. It's just H2O. So this is a double replacement that in the end forms water. Okay, again, we want to make sure it's balanced. One hydrogen, two hydrogen. It's going to have to be a 2. Okay. And then we have NaOH. Oh wait, actually, let me go back here. I wasn't thinking. We have 2 hydrogen, 1, 2, so that works. I got ahead of myself there. 1 chlorine, 1 sodium, and then oxygen, 1, and 1. So it works. You don't have to worry about putting any numbers. But you can see here, on this side, you would say this is a solid, and this is a liquid. Okay. So, but then in the end, you have these. This is your acid, H. This is your base, OH, and you form a salt. And a salt is just something that's formed in an acid-base reaction that usually combines with a halide. Okay, we'll learn a little bit more about these later. Okay, but that is a double replacement where that occurs due to an acid-base reaction. And you can see what happens now on this side. There is no acid or base, so it neutralizes both the hydroxide component and the hydronium or hydrogen. Okay, so those are, you can look at a double and actually say it is a acid-base neutralization as well. The last one we need to worry about, we mentioned Vol. Thing that you probably looked at is something called combustion. And combustion looks like we might have C6, H12, O6. So we'll have that. We'll actually go something different. C5, H10. Okay, and then we put some heat to it. Some oxygen and some heat, O2, and on the other side we're going to produce CO2 plus H2O. Okay. The main thing you're always looking for in these is carbon dioxide, gas, and water. So whenever you see a reaction, whatever it is on this side, it could be organic, and a lot of times it is. It doesn't have to be, but you always produce carbon dioxide and water. And we should always make sure this is balanced. That's a 5. Let's put a 5 in front of that one. And then 10 hydrogen, so we got a 5 here too. Okay. And then so then that gives us how many oxygen on this side? 10, 15. So we have to do a 7.5 to get us there. But then we know we just need to put a 2 in front. Times everything by 2, that'd be 2. This would give us 15. This would give us 10. A little smaller. Gives us a 10, and then that gives us a 10 there too. So we should double check it, make sure we got it balanced. Okay, so we got 10 carbon, 10 carbon. We got 20 hydrogen, we got 20 hydrogen, and then oxygen, we got 30, we got 20, and then we got 10 more, 30. So it's balanced. But this is combustion. It's, like you burn in your wood stove. You put wood in there. It's an organic material. That's some kind of CH whatever. You put oxygen into it. It causes it to burn, and it produces carbon dioxide. It produces water, and also they don't include this in the reaction when you write it, but it produces energy. So those are your main type of reactions. And let me know if you have any questions. We'll practice some of these in class.